This lecture here is going to be on graphing motion. And we're going to look at how forces are directly proportional to accelerations. And we're going to be able to start making general comments to say that if an object is accelerating, there must be a net force present. So here we go. So what is happening in the graphs below? Now we once learned that in a position time graph, straight lines means constant velocity. And therefore on a speed versus time graph, a straight horizontal line means it's also traveling at a constant velocity. And we learned that if it's traveling at a constant velocity, that the object is moving and there is no net force present. It doesn't say there aren't forces present, it simply says that the forces must be balanced. And we called these motions or movements here, we called those dynamic equilibrium, that they can be moving, yet they are not accelerating. Therefore a straight line in position time graph, constant speed, and a straight horizontal line on a speed time graph, constant speed. It is not accelerating. But now when we look at speed time graphs, in this case it has a positive slope, it has a positive acceleration. Here we have a negative slope on the speed time graph and a negative acceleration. And here we have no slope on the speed time graph. No slope, no acceleration, traveling at a constant speed. So now we can make a statement, and we can base it on Newton's second law, where force equals mass times acceleration. So when an object, right, in this case any mass, is accelerating, a net force must be present. Notice net just magically appeared. Very important. So in this case here, it's accelerating. So this graph location right here has a net force acting on it. And here we also have a net force acting. And here there is no net force, that the object is traveling at some speed, not at zero. So it's traveling at a constant speed. And in this case there's no net force present. We would call this one dynamic equilibrium. But now we can venture on to say even a little bit more. We can say that if this is increasing in speed, that the force is in the same direction as the direction of the object's motion. It's increasing in speed, so therefore the force is acting in the same direction of the object's motion. And here where we have the negative slope, the speed is decreasing, we could say that the force is acting in the opposite direction of the object's motion. So now we can start making some connections to forces and acceleration. Because 1 and 2, or these first two graphs, are accelerating, we can say that a net force must be present. So let's look at a graph. So where an object is changing velocity, a force is present. So notice for location A, it has a slope on a velocity time graph. It is accelerating, therefore a net force is present at location A here. But this is no slope on a velocity time graph, so no force is present. In location C, there's a slope. Therefore, a positive slope, there is a force acting in the direction the object is traveling. Notice location D, there's a positive slope. In this case, a force is present. And then location E, there is no force present. Now, if I look at these, I can also even tell which one has the greatest force acting on it. Where I find the greatest acceleration is where I find the greatest force. So therefore, location D would satisfy that. Large slope, large force. And last but never least, where an object is accelerating, a force is present. We can go over this one more time. Location A is accelerating, a force is present. Location B, less force, but still a force present because it's got an acceleration. Smaller slope, smaller force. No slope, no force. Steeper slope, larger force. Negative slope, negative force. That the force in location E is acting in the opposite direction of the object's motion. And that is a summary of the relationship between forces and acceleration.